Hello everyone, this is Preeti. Welcome back to my YouTube channel. Well, in this channel, we talk about data science, artificial intelligence, and programming languages related to data science, such as Python. If you are into this type of content, please consider subscribing the channel. Well, in this video, I'm going to show you what is PyCaret and how we can use PyCaret in our data science project and how it takes all the hectic tasks and make our job easy. This video is the continuity of AutoML's playlist. We have already discussed about AutoML, H2O AutoML, AutoScaleLearn. If you have not watched those videos, you can watch it, but these videos are not prerequisite for this video. Apart from this, I got some queries like how to solve kaggle problems or any real world problem with the help of AutoML. So in this video, I'm going to use the most popular datasets from kaggle. For regression, I'm going to use the HousePrice Prediction dataset, and for classification, I'm going to use Titanic dataset. You can use PyCaret for any dataset and you will see how PyCaret can solve any machine learning problem, any data science project within just few minutes. For beginners, I would say PyCaret is just a blessing. So agenda for today's video is first we will see what PyCaret is, important features, some salient features of PyCaret. Then we will see a demo of PyCaret for both regression as well as classification problem. So let's start with PyCaret. So PyCaret is an open source. It's just free of cost. Anyone can use it. It is a low code because you can do coding in just few lines and end-to-end machine learning library. Well, if you are a beginner just struggling with coding, then definitely PyCaret is your one-stop solution, I would say. Simply you can you can design, you can deploy your machine learning model within just seconds and in any notebook of your choice. It may be a Google Colab, it may be a Kaggle kernel, it may be a Jupyter notebook, anywhere. This powerful library has neatly automated multiple steps in machine learning pipeline, and it's very interactive too. And if we compare with other machine learning libraries, then the number of lines needed to build a end-to-end machine learning model is very less in PyCaret. Fine. So let's discuss about some important features, some unique features of PyCaret. First, you have to install PyCaret. Installing PyCaret is very simple. You have to just use pip install PyCaret. Then importing data. You can import data in two ways. I will show you their official documentation, their official website. Then you have to set up your environment, then create a model, model analysis, model testing, and finalizing and saving a model. Everything you can do here in PyCaret. And well, these are some important features about PyCarets, and we will see everything in their documentation. So let's jump into the official website of PyCaret. So this is the official website pycaret.org for PyCaret. So I will provide the link in the description below. So here you can find tutorials. If you are a beginner, you can find these videos, these tutorials. So you can use it for classification, regression, for clustering, anomaly detection, NLP, associate, rule mining. Okay, now for getting started, you have to install PyCaret. I have already told you it's very easy. You have to use pip install PyCaret. Then for initializing, first you have to get your data. For getting data, you can use done it in two ways. Either you can import it using pandas, or you can even import external data using inbuilt data from my PyCaret repository. Fine. Then there is an environment setup, and it is the most important feature in PyCaret, and this is mandatory step before we proceed to model building. So how we can set up an environment? First, initially the machine learning module should be imported from PyCaret library, and it can be done in this way. If you are doing it for classification, from PyCaret to classification, import everything. Then for regression, so you can done in this way. Then environment can be set up using setup function actually, and where data and target can be passed as an argument. So here it is not actually yeah, here it is. So you can just use setup function, and you have to pass your data and target as an arguments. Now once data setup is done, The output will be an interface of the dataset provided categorical as well as numerical features, missing values, and a lot of more description. So we will see everything in the practical implementation, how everything is done here. So one more thing is session ID. We will also, I will also define the session ID in practical implementation, and it will do all the data pre-processing here. Not only this, it has automatic, data pre-processing. We know that it takes almost 70 to 80% of time during ML model building. So everything is here in this PyCaret. Then apart from this, there is a model training. You can compare your models, create models, you can do tuning of your models. There is model assembly, you can blend models, stack model, then you can analyze of your model. Okay, so there is a model in deployment, then there is a pre-processing, then there are modules. It covers a lot of, almost I could say 25 algorithms, supervised, unsupervised algorithms. So now let's start with practical implementation. Now let's start with the classification problem. Well, I have downloaded this dataset from, for this regression problem, I have downloaded this dataset from Kaggle. You can download it from here. From Kaggle, go to data, and then you can find the data here. And then for Titanic also, you can download the data from the Kaggle. Now I will also upload it on my GitHub as well. You can download it from there. First you have to use pip install PyCaret. I have already installed it. It will take about 1 to 2 minutes for installing PyCaret. Then I have installed pip install SHAP. Actually this is used to interpret the model. Fine. Next I have import some necessary libraries, pandas and numpy. Then after that, what I will just importing my dataset and reading the data. If you are using any inbuilt model, you can use even PyCaret's inbuilt method of importing the data. But here I am using a Titanic dataset. So here I am importing dataset using pandas. Then let's just read the data. So here it is a classification data set. We have to classify whether the person has been survived or not survived. So these are the columns. And for getting some information of our data set, so there are approximately there are 12 columns and 891 entries. So these are all about the entries. There are integer columns, there are categorical columns, there are float columns. So we will see everything in detail further. So I'm just creating a copy of my dataset, and then describe will give you all the description. Now let's handle the missing values. It's not mandatory to handle the missing values. Even PyCaret will take care of it automatically. It will do everything automatically. But if you want, you can do that as well. So here I am just using a simple mean median values. I am just dropping this cabin column, and I am using median. For firstly we will check the missing values, and then we will see that we can see that here age, cabin and marked columns have the missing values, and I am just replacing those with mid and medium. Now we can see that we don't have any missing value. The next very important step, this is the most important feature in PyCaret, that is environment setup. For this I am just importing necessary functions of classification from PyCaret. So after that I am using setup function, and here my data is training data is train underscore df. Then target column, I have to define my target column, and train size is 0.8. So after actually running this cell, it will ask me to continue. Just let me just run this for you so that you can see. So after it started processing, it will ask you to continue. Okay, if you want to continue, then you have to enter here continue. Okay, otherwise you can type quit. Fine, it provides you this data types, and if you think that these are not correct, you can even enter by yourself, and we will do that in regression problem. So meanwhile, just let me take you here. So there are some important other arguments or parameters you can give, such as ignore features if you want to ignore any feature, and if you want to provide any categorical feature, numerical feature. We will do these things in regression problem. So I would suggest to watch this video till end. then you can do a categorical imputation. Then there is a data sampling train test split. By default it is 30 70 30%, but you can also pass any value if you want. And then there is an important feature, that is session ID. Session ID is basically, I would say, it is a random number that can be passed as an argument. This will actually help in reproducibility of the environment in same or in different environment. Fine, here I have given just 2020. You can pass any random number. Fine. So here we can also give numerical imputation as mean. By default it is mean actually, but you can give even median as well. Categorical features you can define by yourself. We will do that everything in regression problem. You can even do PCA here, anything you can perform here. So now this is our result. Next what we'll do, it saves a lot of time because it do all the data pre-processing automatically. So next we are comparing a variety of classification model, and for this we are going to use compare model. Okay, so this is the function we are going to use to compare our models. And here I'm using fold values is equals to 5. You can use any value you want. Fine. So uh, you can see that after comparing model it will give you the best models. Fine. And here I am going to use the cat boost classifier for this problem, for this particular problem. So you can use any problem, any model you want. Fine. So I am just creating a model here. So here it will take only one argument, that is our model name, cat boost. So let me just take you here for comparing model. If you are comparing and you want to evaluate your model, so these are the matrices you can use for comparing. It will use actually, it returns you with these values if you are using classification or a regression problem. So now when you are creating your model, so these, if you are going to use this model logistic regression, then this is the ID you have to pass here. Fine, so don't get confused that while creating a model how you are passing this cat boost, and for this light gradient boosting machine. The another model I am going to create here apart from this cat boost model is the light gradient boosting machine, and for this the ID is light GBM. So you can see here the ID for light gradient boosting. So here it is. Okay, so the ID is light GBM. So you can see it here from their official website. So here the another model I have created is light GBM, and I'm saving it an a variable LGBM. So now let's come to model analysis. Well, before analyzing the model, I would like to tell you that these two steps, setting up the environment and the another one is comparing model and creating your own model. These two are the most important parts, most important features in the PyCaret. Everything depends on these features. So apart from this, giving the target value and your main data and giving this session ID ignore features, you can assign even more features to this. You can give the numerical features, you can also define categorical features, you can give even for numerical imputation, and there are many other features. I would like to say that there are plenty of features you can customize according to your need, and we will do this in the regression while solving a regression problem in our next problem. So, and once the setup is complete, once the setup succeeded successfully, it will give you the complete summary of the model, like session ID that we have given is 2020. Then it will give you target type, that is binary, and their missing values. Since we have already replaced the missing values with mean and median, so there are no missing values, and how many numeric features are there, how many categorical features are there. So we can even normalize our data, we can use PCA, but we have not used any of these things in here. So by default it will use mean as a numeric imputer for numerical imputation. For categorical it will consider constant. So it will give you the whole summary. Okay, so it is using here. So Here you are just comparing all the models and it will give you top 15 models. So after that I am creating two models, one for cat boost and another one is for light gradient boosting. Now for analyzing the model, so which is really a time consuming part in any machine learning process, but in PyCaret it is quite easy. You have to use plot underscore model function for this. So here I am passing the estimator for which model I'm using it as. Here I'm going to use LGBM, that is light gradient boosting machine. So here I'm going to create plots for different matrices, like here I am creating a plot for learning and then I'm creating a plot for AUC, and you can see that how easy it is to create a plot. You don't need to import any libraries such as Seaborn, Matplotlib. So it is quite easy here. So now what I am doing, I am just creating a confusion matrix. So you can see that it has predicted 98% as correct and 12 as that 98% they are survived here and 12 are not survived here. So here it is not predicting well. Definitely there is some part of feature engineering you have to do because the data is not that much cleaned, so you can do that by yourself. Now let's come to interpretation of model. Here you can simply use interpret underscore model function for interpreting the model. So here it will give the feature importance of all the columns, but it will give you these sharp values in the form of sharp values. So here I am comparing both these models. And one more thing guys, actually I have done this plot model function for this light gradient boost machine because cat boost doesn't support this. So well, here I am interpreting this for both cat boost and light gradient boost model. So here I am just doing everything in just one simple command, that is evaluate model. So here you can see everything in just this command. Hyperparameters, you will find all the hyperparameters here, learning rate, importance type, everything will be here. So if you want to see the AUC curve, that too will be here, confusion matrix, fine. So threshold, so this evaluate model is for LGBM, but if you want it for cat boost, you can do that. So here is a precision recall. So everything, even feature importance, everything will be you can find everything here in just evaluate model. You don't need to do any plot model or anything else. So quite easy it is actually. Then for testing you have to use predict underscore model, and you have to pass your model whichever you have finalized or whichever you want to choose, and then along with that test data you have to pass your data which you want to test, means which you want to predict. So here I have done the prediction using predict underscore model, and here is the prediction result. You can find out the score, fine. So after you can finalize your model, whichever model, like here I want to save a cat boost model, so you can finalize your model. Here this function can be used to finalize the model for the last time on the entire dataset. It is not only for particular model, but it will going to save all the entire dataset. Okay, it will takes a trained model object as a parameter. So lastly what we are going to do, we are just saving a model, and the experiment, it will save the entire model, the entire pipeline as a pickle file. So here it will take two parameters. First one is definitely the trained model object, and then the name you want to be saved this model as a string. So it will be the saved model then definitely can be used using a load model function if you want to load the saved model. So you have seen that how PyCaret allows you to build, analyze and evaluate and deploy your model in just few lines of code. The main step here is setting up an environment, then you can compare the model and create your own model, and then you can deploy it. So it's very simple, very easy. Okay, now let's move to our another regression, another data set, that is house price prediction. So it is a regression model. So the step is similar here. You have to install PyCaret. Then I am importing necessary libraries. I am just importing the data set there for the house pricing, and here are the columns. So it has almost 81 columns, and this is the regression model, so I have to predict the sale price. So here the target column is sale price, so I have to predict the sale price. So this is a regression task. So here I am getting some information about my data set. So this is the information about the data set. There are object columns, integer columns, there are float columns. So here I am just checking the missing values. So what I'm doing, I'm just simply filling the missing values with zeros. If you don't want to do it, don't worry. PyCaret will automatically impute the missing values. So next step is setting up an environment, and it is almost similar. I'm just importing necessary function for regression, means I'm importing all the values from using PyCaret.regression. So after that, what I am doing, I'm just creating it using a setup function. So in this setup function, so I'm just providing my data, that is train. So target column is obviously sales price. Then I'm providing a train size is equals to 0.8. So I have already told you train test split by default it is a 70-30 ratio, but you can change it according to your need. Session ID, we know that it is just a random number. So then there are certain more features I have used here. So here I want a numerical imputation to be used as mean. By default it is mean also. So here I have provided my categorical features. Fine. And I don't want these features ID, LA, pool QC. I don't find they are that much, means they have that much worth. So I am just going to ignore these features. So here I have used a transformation PCA, principal component analysis. I am going to use because there are so many features, so I don't want that much features, so I want to use PCA, and the PCA method I'm going to use here is a linear, and the PCA component I'm providing is 0.8. So also I have seen during EDA that there is a multi-collinearity, so I want to remove the multi-collinearity. So I am setting a threshold for the multi-collinearity as 0.93. Apart from that, I'm using log experiment is equals to true. So it will similarly, like we do in a classification problem, it will ask you to continue or not. So you have to enter the continue if all the values you find are correct. So after that, once it it succeeded successfully setting up the environment, it will give you all the details, all the session values and everything. Like I have set transformation is equals to true, PCA is equals to true, and the PCA component I have provided 0.8, method is linear. Everything it will give you here. Now we know that it does almost all the pre-processing here, all the data cleaning tasks it will do automatically. So it saves a lot of our time. Basically, this setup method creates a transformation pipeline, and by default it requires only two parameters. The first one is data. You want to train your data, and the next one is target. So rest all are optionals. They are not mandatory. But there are plenty of other parameters. You can customize your data set. You can customize your model according to your data set or your need. So now after setting up an environment, I just want to check which model performs the best for my dataset. And instead of training your dataset on different algorithms using different models, here you can simply use compare underscore models function. So here I am giving fold is equals to 4. This means that I am going to use 4k fold cross validation for my data, and this feature produce a table of models result in term of evaluation matrix. So all being sorted with a matter model first, then the lower model. Okay, so performance wise it will give me all the values. So this is the table I have got. So according to this model, the extreme gradient boosting is performing best out of all the models. So next I am going to create a model, and for this I am going to use create underscore model, and I am going to use XGBoost for this. So it will create a model for me. Then we can analyze our data using a plot underscore model. So and we can interpret a model similarly that we have done in classification model as well. So it will definitely, it gives you a feature importance, which feature is important or which is not. So it is giving us component 1, 3, 4 instead of these column names, because we have set PCA here. So that's the reason. Now when it comes to model testing, you can use test your dataset, predict your dataset using predict underscore model, and you have to pass your the object you have created for your model, that is EGB, and the data you want to test. So after saving it, you can finalize your dataset, and then finally you can save your model. So in this video you have seen how we are able to build a model, how we are able to do a hyperparameter search on our model. Finally we can take a model and deploy it. So you have also seen how we can analyze the model, okay, using simple commands. We can easily visualize our data, and all these things we have done in just few lines of command. And this is not only this much you can do with PyCaret. There is a lot more you can do. You can even normalize method using the normalize underscore method. You can use transform underscore method, and then feature selection. There are a lot more things you can do with PyCaret. You can tune your models with the help of PyCaret. You can ensemble models or blend models to get a better results. You can stack your models. So there are a lot more things you guys can do. So I just suggest to explore this PyCaret library. It is really useful, especially when you are a beginner. It can save a lot of time. So this is all about PyCaret. I hope you have learned something. So guys, please like the video and do subscribe the channel. Stay tuned. Thank you so much. Bye bye.